Good evening, everyone. How are we all doing? If you can hear me and it's loud and clear, kindly let me know. If I have to adjust myself, I do so. If it's okay and you can hear me loud and clear,
I can hear you loud and clear.
powerful, and then we proceed. Um, Tonight, I'm sharing my screen. If you don't have the document that is being displayed, kindly let me know so that we reshare on the platform. If you have it, kindly give me a thumbs up so that we proceed. Okay. Uh, okay. Mr. Anand, do you have it? Okay, Mr. Anand has it. Okay. Mr. Kote, do you have the document that is being shared? Okay, so I guess his network is a bit slow. Right. So tonight we are continuing from the where we left off, which is on the revolution and all that, right? So now we proceed with the database architecture, right? And before we take off, let's do a recap. Okay. Let me see if it's recording. Okay, so we start. It's already started. All right, powerful. And so, getting off started, we learned in the previous lessons, right? So far we've learned that data is a raw fact, which we all know. We've learned that database is an organized filing cabinet for data, right? And then we also have database management system, which is the office manager that runs the filing cabinet. So we have a filing cabinet that is organized and it's called a database. And we have the management software or the system, which is DBMS. So these two are different, okay? Let's notice. So throughout our previous lessons, I was trying to distinguish between these two, okay? Data, database, field, and so on, all right? And we learned what a record is, right? We learned what a field is, and we learned what a file itself is. We also went ahead to talk about the 4 evolution stages of the of data and database for that matter, right? And then we talked elaborately on it. And so now that you have the database, which is an organized filing cabinet. So the data is a raw fact, right? And then the database is an organized filing cabinet, right? That is keeping that raw fact, which is the data. And we are now saying that the DBMS or the database management system is the office. It's like that office manager that has been employed to run or take care of the office cabinet that contains the organized cabinet, which also contains the raw fact, which is the data, right? Now we are going to imagine something. I want you to picture this. So I'm using it in an office settings, right? Now imagine that this office cabinet that I'm talking about, this filing cabinet, this is inside your office. It's your big office building. You have this cabinet inside the building. So different people need to use it in different ways. Do you get it? So the boss, if you are the boss, right? The boss wants to see only the sales report, right? The accountant needs to see salary details. You get it? The IT person needs to know what the IT person needs to know which cabinet drawer holds which folder. Do you get it? So this is how I want you to. So the boss needs like he wants the business to go on, right? So the first thing as a boss, when you enter your business, you want to check your sales because that's what brings in the money. You see, The accountant is checking or balancing some monies, also needs information on the salaries as well, those details. So we all fetch these data from the various portions in the cabinet, right? But you, the IT person, you know, you need to know which cabinet drawer holds which folder so that you can direct the accountant that, oh, draw folder 13. That's where yours is. When you go to folder cabinet drawer, let's say cabinet number 2, drawer 19. That's where you see your accounting details or data. Oh, boss needs sales report, right? Okay, boss, please, yours is at cabinet 3, drawer 14. You get it? So you, the IT person, so this whole database system thing, no, that is the role of the DBMS. So the DBMS is managing the whole thing. You get it? Powerful. So now the question becomes, how do we design the database? You, the IT person, how do you design it? You get it? And so that everyone gets what they need. How do you arrange things without confusion, without chaos? That's exactly what database architecture, this topic today, is about. You get it? I intentionally went back so that I'll come forward a bit so that you get what we're about to do. So today, database architecture in plain words, right? Plain words, you say. So database architecture on. So the architecture of databases, so how do you look at it? So look at it like the skeleton of a building. Do you get it? Like the blueprint. So when I say blueprint, person me use blueprint, you know, but blueprint, you know. How many of you don't understand blueprint? Hands up. If you don't understand blueprint, please answer. Oh, I'll gladly explain. Okay, powerful. That who is that? Senyaku says he doesn't understand. That's a very innocent gentleman there saying he doesn't understand blueprint. Please, who can explain to him what blueprint is? And I must say, me correct. Me answer my dear. Anybody? Okay, so let me try to explain blueprint. So blueprint here. Please, do you understand tree? I'll move from tree to English. Okay, tree English. Or English to tree. So you know, a blueprint is typically something like a detailed a detailed technical drawing of something. Just look at it like that, like a detailed technical drawing, or traditionally, you know, white lines of an actual thing that needs to be done. They start doing it in the shadow form of it. So instead of the original thing, you have something to begin with. So you look at it like something that is a skeleton for you to stand on to do the real thing. Do you get it? So uh, so normally the architects that we know, right? What they do is that they leave technical details and they draw certain things. You, normal person, when you see it, you may not understand unless you have technical details. It is the actual building you want to build, but they have drawn the inside of it, like the skeleton of it, the bones part, so that you stand on it to draft that beautiful building you are imagining. So the first type of those white lines that they do, this is a blueprint that they stand on to follow. You get it? To build the actual building. So in general life terms, okay, it is before I come to general light, so these lines these architects have been drawing, they normally use white lines, or in the past they used to use blue a lot. So those days, let me get a picture for. I was showing a customer some blueprints of a plan that I did some time ago. Let me fetch in my folder and see. Okay, I think I have it. But how do I share it? Okay, so I'm going to put it on the WhatsApp page, right? I'm going to put it on the WhatsApp page. So we are all on the IT. So I'm placing it on the WhatsApp page. So this is an example of a you can say blueprint. And akoshe, okay. Okay, so if you watch the WhatsApp page, who has posted an audio on the page? What I'm talking about. Why are they chatting on the page? So if you look on the IT makeup page, you see that I've posted something, right? This is an example of the blueprint. So this is where this term came from. Please, are you seeing? Let me go. I can see I'm on the WhatsApp page. Please, have you seen what I've posted? Who has seen what I posted on the page? Or is my network powerful? So this is how the name blueprint came about. But nowadays,
hello, I can't see anything there. I can't see anything there.
Which page are you on?
The IT makeup lecture.
Makeup lecture. I better send it to your DMO. I don't know which page you have gone to discover. So, Mr. Nyakon, please check your DM.
Oh, okay. I thought you said you sent it in the IT makeup lecture.
Yeah, but I sent it in actually, but you look in your DM, okay? It's because of time. Okay, so this is an example of the. So this is where the word started from. You get it? So it is. So when you look at it, how would you know that is your building? You get it? This is what Ghanaians we call building plan, building plan, building plan. Please, do you get it? So we say basically that this is the blueprint of the building itself. But when you look at it, it's not the building. So, but we stand on it to do the building itself. So this is where the word originated from. And then now we generalize it that blueprint is something that is a prototype to the main thing, an example to the main thing. Please, are you following? Are you following? Are we following? So when we say it's a blueprint, this is what we are talking. It's a shadow of the main thing. You see, it's a replica of the main thing. So that's what blueprint. Who else doesn't understand the meaning of blueprint? Okay, so please let's continue with database architecture. All right, so now that we've talked about data, field records, and so on, let's move on to the architecture side of it. And I'm saying that architecture, right, in this context where database, we are talking about database architecture, means the structure or blueprint, right, of something. Let's just do it like that. Now let's link the data to it. So I was talking about the structure of a house, architecture, the walls, rooms, as you can see in the building. This is the framework, the skeleton. For a database architecture, right, architecture in this context in database is how the data is organized inside. Now, are you getting it? Are we following? Now, when we talk about architecture in relation to database, we are talking about how the data, you remember that the scenario I was giving, that data is the raw files, and then which one else? The database is the organized filing cabinet for data, right? That the data is kept in. And then the DBMS is the office manager that is in charge of running that file cabinet or filing cabinet. So in that order, right? Now we are saying the architecture of a database is how the data is organized inside of it, how each one is structured properly, placed here and there. So this is what this topic is about. Now let's go further. So it does it from the top to bottom, right? Are we following? Let's follow. Let's follow. And I mean, follow for follow. Mr. Kote, make sure about I didn't know upia no asaba upia no. So yeah, so how the data is organized from the inside, right? And then from the bottom to the from the top to the bottom. Do you get it? Everything is properly organized. So the most important idea in database architecture, right, is called it's a phenomenon called the three-schema architecture. The three-schema architecture. Now I'm going to break it down. This is also known as, some of you know it as ANSI. Okay. And then, but it also has another name, SPARC. We are going to talk about this three-schema architecture. Do you get it? Now, don't let these names confuse you. All these things are simple. I'm going to break all of them down. So the schema, let's take the words one by one. Now, by the time I'm done with the words, you'll be able to know by the definition when we put them together, right? Good. When we say schema, it just means a plan, right? Or a map. Do you see, of the data? So the data that you have in the cabinet, now I'm standing on the scenarios to move forward, okay? This is why it's important for people to join the sessions early. And yes, I will join you later. You'll be lost in the wild others. All right, so let's continue. The schema is just the plan. And then it's just the plan, or like you think of it like a map or a plan. Do you see? To locate where which data is. Do you see? It's a plan like the architect, that what I've posted on the page. You can follow the blueprint to know that, oh, this is the living room, this is the kitchen, this is a washroom. Oh, we can pass here, and this is where this is. You get it? So this is where we are going. So this model that we are talking about highlights these things. Okay, let's move on, please. I hope I've not lost you yet. I know you. I'm not going to lose you. So the three-schema means three different plans for three different types of people. So different types of people, we are being given different plans, and it is mainly centered on these three plans. You get it now? Because the database there is the drawer inside the main frame of the cabinet. And then we are classifying these kinds of people in three main groups. And this is why we call it the three-schema architecture. Simple. Now, let's delve into the three-schema. Let's explain it. Let's enter a restaurant. I think that one will get it. Okay, so look at it like a restaurant, right? Today, I don't break them like stone quarry. So we are in a restaurant, right? So we have the customer, right? And then we have the chef, and then who else? Who else works in the restaurant? We have the customer, we have the chef, we have who? The warehouse worker. Who is the where? You know, those people who bring the ingredient, are they called warehouse worker? I'll name the warehouse worker now. Those who bring where the storeroom or storekeeper, those who have done restaurant. So the person who brings the ingredient. So the customer, okay, what you will see as a customer is your menu. When you enter the restaurant, you see your menu. Simple. You see it, this one and the price, this one and the price, this one and the price. You are the customer, no? You are an external level person. You are now coming into the company, and there's a type of information you have access to. You get it? And then as a chef, you are privy to a certain type of information. Do you see? Yours is the recipe book, right? That's the information. The recipe book. Mo terms no man can hear mon can you. So yours is the recipe book, right? But you are a worker. You are the one cooking the food. You see every ingredient, every step of the way. You are the one planning. You know, this one should go first. This one should go second. This one. So in this Three-Schema, no, the customer will be external. So you say you are from the external level. Then the head chef, no, or the chef of the place is in a level called conceptual. Or no, or you soon drink and then a concept and a BB and break down everything. Oh, put the food, don't put salt inside like this. You know, like the way Mr. Annan has been putting too much salt in the food. You see, so you tell them a little bit of that, a little bit of that, a little bit of that. Do you see? So, and then we have the one who brings the ingredients. This one is a worker inside, but this one is the one who brings the actual ingredients for the chef to cook, right? So this one we'll call the person uh, an internal level person, right? So these are the three main parts of the Three-Schema architecture. I'm going to break it further. So we have the external level, conceptual level, and then internal. Don't worry, I just use this random restaurant experience so that you remember, you can associate what I was talking about to the various terms. Okay, so it was intentional. So external level, you have external level, and then you have conceptual level. So external level, the customer, right? And then conceptual level, which is the chef, right? And then you have the internal level, right? The warehouse worker. Do you get me? So all these three people are looking at the same restaurant. We are all standing and looking at the same, but we are seeing the restaurant differently. One person is there to eat, and so he'll be given a menu. One person is the one cooking. Another person is the one bringing the ingredients. So you see, we are standing in the same place, but we are seeing things differently. You get it? So the external level, this is what each is basically what each user, right, or app sees. So when you open a database management system, what you are seeing when you open a software and it's keeping the details of people, you, the user, right? When you open it, what are you seeing? This is the external level view. So all this Three-Schema architecture is saying is that these three people in the Three-Schema architecture, they are looking at the same thing in different angles. Please, are we following? Are we following? Yeah. So we are looking at the same thing in different angles. So how the user will see it is what we call the external level. Do you get it? And then we also have I'm sorry, there's an insect on my eye. So yeah. Aboy, yes, so we different users use different menus, right? So a student sees only their grades on the school's database platform. For instance, MIS. You go there, You as a user, your information, the information you see is different. The professor who is cooking the grades, who is cooking the grades, he sees all the students in their class. You will not see all the students. You go and see your own. But he will see, you see, the angle is different. So for him, he will be conceptual. The student will be what? External. Are we following? Because he is the user, the basic user. And then the professor is the cook. And then the registrar can change, you kind of saying, enrollment data. The registrar, the person who is bringing, so he's the one bringing the ingredients for the professor to cook. So you see, so over there, the registrar is what? On the Three-Schema level, the registrar will be what? Who remember? Internal level. So the customer, the user, the initial user is the external level, right? Doesn't have access to the software, doesn't have access to the app. And then the head chef is the conceptual level. And then the house worker is the internal level. In this case, the student will be what? The external level. The professor will be the conceptual level. And then the registrar will be the internal level. Because he is inside the system itself to be able to write or rewrite the system. All right. And then that's how we go. And so the key points, users never see the full messy database. Do you get it? We don't see, we the users, when we just go with our details. We want to imagine the day you go to watch your MIS, the grades on your MIS, you go and you see a bunch of codes on there. You tell the school that you are not supposed to see this detail. You went to see a particular information. Do you get me? The same thing with the lecturer, the same thing with the registrar, or whoever has access to the administrator side of things. And so the same thing with the conceptual level, which is the complete logical design. And then you can have how do you call it? The internal side, which is also what goes with. So the external level goes with each user. You get it? And then the conceptual level is the person with the complete logical design. You see, the one who maintains it. You get it? The one who is maintaining it. And then there's a one behind everything who has a certain level of access into the physical storage. You get it? Where normally the codes are written. And so this is the internal level. That's why we call it the internal level inside the physical storage. So which files on which hard drive, what indexes exist, like the index at the back of a book. You get it? At the back of a book. So for you to locate which topics, do you get it? So which topics are inside the database for you to even access what information you need? Like this kind of person who is the internal level person has access to all this. How data is compressed. Do you see how data can be compressed so that it will not be cumbersome? To not become, we compress data so that it will not be too, the size and things will not be too many. How it can, or encrypted so that it can become what? Secured. We encrypt data so that data can be what? Secured. So this internal level person, he is in charge of all these things. But the conceptual person there, his is to design or maintain, you get it, the database. You see, it's like a caretaker or a manager. You get me? But we have the actual person behind the scenes, and we call them the internal level or the ones in charge of the physical storage. So basically, that's that. Yeah. Who doesn't understand up to this point? All right. So basically, normal users never see the internal level. It's only database administrators, DBAs, database administrators, and then the DBMS software. The DBMS. Normally, when you say the DBMS, you shouldn't have software, but we just say it so that it's just like saying, those rhetoric things we've been saying. So DBMS software, you see. So how do they connect? There are two kinds of data independence. Now, between each level, right? Each level, okay, there is a mapping. You see how the three of them connect. We use a particular way called the data dependence. So the three at each level, the external level is able to communicate with the conceptual level, and then conceptual level is able to communicate to or with the how do you call it, internal level. Do you get it? And it uses this concept called the data independence. So what is logical data independence? Okay, so before we talk about that, there is a particular mapping, right, that is done between all of this for the three to connect, right? So when this happens, it gives us two superpowers. First power that it gives us when you are connecting these three together, the first superpower is that we begin to have something we call logical data independence. Logical data independence. Now, we can change the conceptual level, right? The recipe book, the one who is holding the recipe book, without changing the external level, which is the user. We can change, we can tap. So anything that helps us to change without it affecting the order, right? In a sensible manner. So an example is we can add a new phone number, right? We can add a new phone number column to the data, to the students table. The students menu doesn't have to change unless we want it to. So just because you have added something doesn't mean that other things should be affected, basically. Do you see? And it's through this concept that we call the logical data independence. Do you get it? Fine. And then we also have the second superpower. Do you get it? That we get when we are trying to connect all these three concepts together. Do you get it? So we have the superpower that allows us to make changes, right? Without it affecting another side of the data. It only affects what we want it to, and that superpower is called the logical data independence. Please, are you now getting it? That's why I didn't rush to explain it. So now we also have, apart from the logical data independence, we have physical data independence. Physical data independence. Now, what is it? It is that superpower that allows us to change the internal level or the warehouse shelves, right? Without changing the conceptual level. So the first one, we can change the conceptual level without changing the external level. The conceptual level is like in the middle, right? And when we can change the middle, which is the conceptual level, and it will not, the external level will not change. Do you see? That is what is the logical data independence. Do you get? We only let it change what we want to. Do you see? So, but with this one, the physical data independence, we can change the internal level, the warehouse shelves, without changing the conceptual level. This is the recipe book. So this one has gone a step backwards into the internal side without affecting the first one. We are changing the middle, the conceptual, without affecting the external. Now we have gone back to internal, which is the writer or the programmer side, or the one who brings the ingredients. You can change the internal, right, without changing the conceptual. You get it? So let's get it. This is what we call the physical data independence. So we move database to a faster hard drive. I'm coming. There are some people who are specialized in calling me when I'm teaching. Okay, so we can change the how do you call it? Why am I confused? Edwuma no edin pa edin rough. We move the database to a faster hard drive, right? We move the database to a faster hard drive to add new indexes. The head chef doesn't need to know. Do you see? The recipes stay the same. We move it. So inside, because the internal side is where the storage, the physical storage is. So this one, we are not changing a column, unlike the conceptual side that has to do with the lecturer. The lecturer can change something without affecting or without the student seeing. That's the conceptual logical data independence. With the logical data independence, the conceptual level, right, person can change something without the student or the external level, the user, seeing it. Do you get it? And with the physical data independent, we are talking about the physical storage. And so the one who is behind MIS, who is coding, who is behind the system itself, the one who is behind the system itself is able to change something without the lecturers also what? Knowing. This is basically, and they do that with, let's say, for instance, changing the server or adding more servers to it so that they become faster. So in so doing, you now have multiple places to fetch your data, right? This is what we are talking about. These are the two superpowers we gain when we are practicing the three-schema architecture. Do you get it now? Shall we flow? Shall we flow? Ipacho, young flow, and I say, most correct. Okay. All right. So now it's unfortunate that Mr. Annan, I think the storage for Teams is now full. So how do we get the recorded sessions now? Because it doesn't save. It doesn't save anymore.
Space.
Come again?
Space.
I should use what?
I have released space. There's space. I have freed up.
Okay, but I can't hear you well. But I mean, I want to understand that. Okay, so you've added some space to it, right? Or it is basically solved.
Yeah, he said he has free some space.
He has free some space. Okay.
Yes.
I wasn't hearing. Yeah. It's not clear. So, yeah. So these are the two superpowers within the three-schema. Three-schema architecture. I'm talking about the recorded class. So, so the three-schema architecture. Now, these are the two superpowers that helps us to do changes within, or that happens when we are trying to do changes, or that we follow when we are doing changes. You see, or that exists. You get it? So why are we even talking about this? Why is this superpowers a big deal to even talk about? Do you see? So in the olden days of computer filing, right, or computer files, if you change how data was stored, every program that used it would break. If you change one thing, every other program that you use will also break. When we say break, it means that it will not work. It will not function as how it's supposed to work. The code that you code or you write, it will break. So when you say your code has broken, it means that, when your code breaks, you see this HTML thing that I do, it's a coding thing. No? So imagine a code breaks, like the recent one I did for today's own 203, right? I realized that there were some codes that were breaking inside. So I need to update it. Like, for instance, I added a game inside, right? Where a simple game where when you are tired of learning, you play the game, you rest, then you continue. But you see that when you start the game, it plays and then it pauses. You see, but I'll look at it because the idea was that you are not supposed to play the game too much. So it was with that mind that was done. But I think I'll extend it a bit. You can at least play it for 2 minutes, but then you continue learning. And I think the audio too is not able to pause when you play because some people want to learn on the go. They want to listen to the slides. So that audio, the embedded audio in it too, there was a breaking over there. So it's not able to function the way it's supposed to. You get it? So these are some of the things. So because the code, there's a problem in the code, you, the user, you will see it in the way it functions. So when we say a code has broken, this is what it basically means. And sometimes too, it means that it's not working at all. Do you see? So with databases, you can upgrade storage. So in the olden days, when you change how the data is stored, every other thing, because when you were coding, you specifically mentioned that this data should be fetched. If you are a web developer, you are designing a website. When you are fetching for an info a picture, everything is locally made. Every picture, I'm trying not to use technical terms too much. Every picture is on your PC, and so when you tap from your PC and you open the website through the HTML file, it begins to search for the location of, let's say, if there's a picture, it searches for the location that you placed. So it will, if that picture that you are using for the background is on your desktop, and in the coding you wrote that the picture should be fetched, there's a picture with the name so and so and so, it's a JPG file on your desktop, so it should fetch. It will go and look on the desktop to look for a file. Before that file, when it's found, it will display as your website or on your website. So imagine you go and remove it from your desktop and you place it on downloads, and you are trying to open that same code, right? You open the file, will you see the picture? No, it will be affected, and it will affect the rest of the code where you made reference to the location of that picture. Do you get it? And this is what we are talking about. Are we following? So if you change where the data is, so every program, every code you wrote will be continuously affected. So with databases, you can upgrade storage or reorganize your tables without rewriting all your coding or all your codes. You see, there's a way to rewrite, and this is what we call the data independence itself. So it is from the data independence that we fetch the physical data independence, and then what's the other one? The logical data independence. So the act of being able to upgrade your storage. So you see that both physical data independence and then the logical data independence are talking about your modification of your database. Do you get it? The modification of your database. And so you realize that then the fact that we are talking about database has to do entirely with organizing your data or upgrading or modifying, right? Modifying your data or making changes to your data without it causing a ripple effect across board. This is what we call data independence. I intentionally didn't bring it in the beginning. I made us talk about its part before we came to what it means. So if you don't understand, let me know so that I go over again. Who is not flowing? Who is lost? If you are lost, please be truthful. And you should be writing too. When you write it, it will follow a certain pattern. Then when we finish, I'll let you draw a pattern. You see that everything is linked together. You see the thing. This is why it's necessary to be writing. Okay. All right. So let's continue. All right. So this is why this whole thing about data independence is so important. And then the various types of data independence is also so important. Now, let's talk about a concept. Where does the database itself know? Where does it live? Where does it reside? Now that we have understood the three levels, the three schema levels, right? Let's talk about where, you see, three schema architecture, three schema architecture. So, and we have talked about how it how data independence helps us to make changes without affecting or causing a ripple effect to other programs. And we talked about the two superpowers in the data independence, which is the logical data independence, and then the what? The physical data independence. You see, and we say the logical is where the conceptual level person is able to make changes without affecting the user, which is the external level. And we said the what's the other name? The physical data independence, which has to do with the physical storage, which relates to the internal level person, right? Has to do with making changes from that side without affecting the conceptual level person. You see, so it's like that. So those who are writing, this is for you. So client server architecture, this is where the data lives. So when we say client server, client server, client server, we are talking about where the data itself is residing. The location, where you see the data of your application, the data of the code of your website and everything, where it is saved, the storage, those places, it's called the client server. So we are going to learn about the structure of the client server, just like we've learned about the architecture of the three schema. Do you get it? So let's learn about the client server architecture. Now that we understand these three levels, you understand about the database, how the database software is run. Do you get it? The database softwares, how they run. So in the past, one computer did everything. Now, in this modern world, 2026, right? Now the works are split in different portions. So we have the client and then we have the server. Now let me talk about the server first. The server is just anything that is powerful, a powerful computer that runs the database, the filing, the cabinet. So you see that thing that we were talking about in the beginning, filing the cabinet, the manager, you see, management of the whole database is what we call the server, the one that keeps the data itself. That's the server. But when we say client, the client is your computer. So in database or in web development or in app creation, right? Whenever we talk about clients, we are talking about the user's device. So you are the customer. You, the customer, we call you. What other name do we call the customer? Client. Do you get it? So you are looking at it. Do you get it? You don't have access to certain levels. You get it, like the conceptual and then the internal. And so we call you client. So your device is the client. Your computer is the client. Your phone is the client. Your web browser is also a client. Do you get it? Your web browsers like Chrome, Safari, those ones to their clients. So they ask for data and then they interpret. You see, so they have an inbuilt thing in them, like the web browsers, that interprets specific data. Like let's say web browsers interpret HTML well. So you see that when I post the file, I'll tell you open with Google Chrome. because they have an inbuilt code that helps to read the content, and they already have some features you see embedded in them. So the code just instruct them, use your feature, this type of feature that you have to show them this. So that's how come the files are also lighter, please. Okay. All right. Powerful. So we have the server and then the client, right? So two common setups that I want you to know. Okay. We have the when it comes to the architecture of the client and the server architecture, or how the framework or the skeleton or the blueprint is, we have levels of the framework. You know, when you are building a house, you have the time where they are laying the foundation, and then you have the lintel level, and then you have the house in a skeleton with the roofing. You see, they are in tiers. When I say tier, TIER, they come in levels. You see, they come in phases, phase 1, phase 2. So it's another way of saying phase, PHASE. You see, so we have tier 2 architecture, we have tier 3 architecture, right? For the client server architecture. And then we have for the purposes of what we need to learn, we'll learn only tier 2 and tier 3. Okay. So with tier 2 architecture, it's very simple. It is your app. You see your app, which is the client, your browser, your device, your computer. It talks directly to the database server. So where the website is not on your phone. The website, let's say Google, is their server may be in Ghana, where they've stored the details of what you are searching for, or the website that you are about to type. They have a place where they've kept all the database in. So what your network is doing that is accessing through the app that you are using, is accessing the database server to bring you the information you need. It is accessing it directly. So with the tier 2, the app, which is the client, accesses the database server directly. So an old Office program on your desktop computer, right, would fetch the data directly from the server. Now, when you have a tier 3 architecture, which is the modern web, what it does is that your client, which is your browser like Chrome, instead of fetching it directly like the tier 2, it will use an application that runs the business, something we call the business logic, right? So we call it application server. Do you get it? So instead of having a direct link in times past, this tier 3 architecture uses your browser through an application server, right? And then runs a certain business logic to access database server. So that means that tier 3 has a certain third party inside. The client doesn't access the database directly. There is a third person in the middle called the application server. So the application, your internet will first reach out to the Opera Mini, the Chrome, and before the Chrome will reach out, you see, to the website itself. And when it's coming to Chrome, will receive it before you receive it. And it helps in security. You get it? When it passes through them, they're able to tell you that this website is secure. This one is not secure. You see, so because there is a third party, this is the third tier. So that means a 3-tier architecture of how the skeleton is, or how the inside, or how the thing runs. Please, are we understanding? Are we flowing? Gonja Barracks. Okay, so now example of the 3 tier architecture. Why am I broke from crash? So when you log into your university portal, do you get it? The MIS, for instance, you see your browser is the client one. You have a client one, your browser, and then the website's back end. The website back end becomes client two. You see, there's the app server. So the app no, we use on the website. On also on the website, and some website na person will reach data na nkasa person reach and also so need database. Do you get it? And so this is the two types of client server architecture. Do you see that we have? We have the 2-tier and then the 3-tier. You get it? So why do we have 3 tiers? Like I said, number one, security. If you are doing something and there's a third party inside, when the problem comes, the third party will solve it for you because he's the one that you have employed for him to do that. But the problem too with the third party is that he will have your information and he will be using that to show you adverts because you like to visit those who has a lot. Do you get me? Because everything that you are doing passes through him. Please, are we following? If you are here, raise your hand. Let me know that you are listening. Hey, Obi Eniha. Wow. Any. Okay, Mr. Nyako is here. So, security, scalability, one of the reasons why using the 3rd tier or the 3-tier is important. 3-tier architecture within the client server architecture, using the 3-tier is important. It's because of security. That's number one. Number two, scalability. If you want to do a lot of things, you can classify, you can do it big time. Do you get it? You can do numerous things at the same time. You are able to open multiple tabs and be working on that same app, on that same browser, or that same whatever the system is that you need to fetch the data. And we are just using websites because that is the common one that you are conversant with. But any system that allows you to fetch data that you need, right? Apart from the websites that do. So every website, the videos on the website, the files that you need to download from the website, they are all in their server, their service or their server. You see, which is their database repository. You see, the place where the files are kept. You see, is what we call the repository. And so security, scalability, and separation of concerns, right? The database never talks directly to users. You see, it never talks directly to the users. It talks to the client, and the client interprets it to you. Do you get it? So that's with the 3 tiers. But with the 2nd tier, everything is done directly to the user. You see, so with the 2 tier, you virtually need to be a programmer or something. Do you get it? That was in the olden days. So in the olden days, if you're on a computer, you need to be. You see, the more time comes, the more coding becomes of higher languages. It becomes easy for people to communicate. Do you see? But in the olden days, you realize that things were on the low end, where languages were on the lower side. When I say lower side, it means that you're communicating to the computer directly. Nowadays, as time goes on, more and more clients' systems are being introduced for companies to step in and do certain things that you would have gained or you have gone to get skills to understand. So now they are bearing those consequences and we are paying them for it with our data indirectly. And that's also how they make their money, the companies who give you these softwares. So putting it all together for someone new to these things. So let me put. So in a nutshell, what you have learned is that so let's say in the University of Ghana, right? You want to store students' records. Do you get it? You want to store the whole university, they want to store the student record. What do? They have an external level person, which is a student, or people, which is the students. The students see the login screen, right? And their own grades through the portal. The professor sees a class list, right? The registrar sees everything. This is the external level. The conceptual level, a database designer draws an ER diagram showing student, course, grade, tables, and how they connect. It can also be the professor or the lecturer himself. Do you see? Who is in charge of that conceptual level? Do you get it? And but it's basically the one, or the database administrator. Do you see? But this person doesn't have right to. You remember the diagram we were looking at on who uses what in the office, where there is a server, a database system, where we were last in our last class. This is what we are basically using. Do you see? We have basically classified everyone into 3 main groups. Do you get it? So the data, this is the conceptual level, is where the database administrator will belong, where he will just maintain what have been created by the programmers who are on the internal level side. You see, this is an IT specialist who creates and code the whole thing that have been designed by the conceptual level person. Do you get me? So this is basically what we are talking about. And then we have the client server. What do they come in with? They come in with the students access it via a website, 3-tier website, because we are in the modern days. They can't use the 2-tier. We use some platforms called Sakai, MIS system, right? These are our tier 3 or 3-tier platforms that we use. And the database server sits in a locked room somewhere. You may not have, imagine if Mr. Anna, for instance, the way he's hot, if he gets to know where the server of University of Ghana is, he would do a forensic this thing and go there and make some changes there. You see the thing? You see, like those Kakalika movies, is it Kakalika movies, where they go on haste and they plan, they map out where the location is, and they go and pick something from the server. It shows you how data is very, very important. Yeah. They can alter the whole program by fetching where the data is and then use it for their own benefit. So in all, because of data independence, so if the IT specialist or the programmer is buying a new hard drive, which is the internal level, right? The student's view, which is the external view, doesn't change one bit. Do you get it? Because of data independence, the person coding will need to expand. Do you see there? Perfect example. When I was telling Mr. Anand that the capacity for the teams for storing the recorded video, recorded sessions of the teaching sessions, it wasn't storing anymore. He said he has updated it, right? Or he has increased the capacity. Is that what he said? Right. Yeah. So because he has increased it, it didn't change anything. It didn't change our coming here. We're able to still log in. It didn't change Teams. He was able to update or increase the capacity of the storage without it affecting anything, right? Even myself, I didn't notice it. We've been able to have our class successfully tonight. Do you get it? And so it should tell you how data independent. So it's the data itself is independent from any other change that you make. It's not affected by it. And this is what we mean by data independent. And if the registrar wants to add a new emergency contact, hey, Mame Vida, if the registrar wants to add a new emergency contact, like column, to the student table, like the conceptual level, the student's menu doesn't break. Do you see? So this is where we are talking about the internal level architecture. Do you see where it has to affect, or it doesn't affect the conceptual level person? Do you get it? It's so awesome. So when you understand the dynamics of and the beauty of these things, as simple as we've done today, you see that, oh, everything is not as scary as it looks like. But when you don't pay attention to it, or you don't join class early, like I'm sorry if it has to mean something personal to that's where. So let's look at the final summary table for today. Today we talked about the external schema, right? We've learned that it means what each user sees, right? The external schema, or the customized view. And then we've also learned about the conceptual schema, which is the full blueprint of all data and rules. The full blueprint of all data and rules is the conceptual schema. And we've learned about the internal schema also into details. And we learned that it is how data is physically stored on the disk. You see, internal schema. And then the logical independence is logical independence. Who remembers? Who remembers the logical independence? Okay, let me say it for the sake of time. But if you have it down, you can just read it. All right, so it will be great. The logical independence is that part where to change the blueprint without changing the user's view, which is the external level person. The logical side, okay, has to do with the conceptual person, right? So the fact that the one in the middle is the conceptual is able to make changes without affecting the external level, which is the user. And then the physical independence is where you are able to make changes to the storage, right? Which is normally those who write the code, and it doesn't affect the conceptual level person. Do you get it? And so this is so the change storage without what changing blueprint. All right. And then we talked about the client server as well. And we learned that the client server is a database where the data is a repository, or the location where the database lives, right? Is the place. The database lives on a server. Do you get it? Users connect remotely. When you visit the website, you are accessing the database that is living on a server. Do you see, remotely with your phone? And we learned about the concept of who a client is and what a server is, right? And we also learned about the 2-tier and the 3-tier. And we learned that the 2-tier at the app, or the client, talks directly to the database or the server. And the 3-tier, there is a third party, or the middle person, or the middle app, where there's an app server that sits in between the user and the database. Do you get it? So this is the summary of the details of what we've learned tonight. I wish tomorrow, do you have a class? Do we have a class actually? If we don't, I would like to take the session tomorrow so that we continue. All right. So basically, database architecture, right? Separate what users see from how data is stored. So it changes at one level, never breaks. Yeah, basically that's what it means. So the changes at one level never breaks, no matter what is changed at other levels. At different levels remain the same. So this is what we learned today. And tomorrow, God willing, I think I'm still projecting the same screen. So you can see it's because you have the slides, and I was explaining these things today. And I think we've done that justice to these ones, right? All right. And so the key inside database is what lets companies change their storage or recognize. So you see that I went into details on these ones. I was trying to embed some videos on them, but because of time, I had to skip. Maybe in our updates, you see me adding the videos, okay, so that we have them. But because of time. So tomorrow, if we have the time, we'll do the data modules, right? The evolution of database thinking. But I think because we've already done these ones, we're gonna skip it and then move on to the next topic after that. And this is how important those catch-up moments were. You see that we'll just run on to the next one, which is ER modeling. And wow, light out. ER modeling. Hey, these people, wow. ER modeling and business rules, drawing the database blueprint. Sorry, my attention, the light out, I was planning to now go and cook. So I've been completely disoriented. So
You have to order.
we have to
Place an order.
Triso over Miss Kawa. Like yesterday when they give the light out. I think those who are around my area, you saw that when the hours went out around 1 p.m. and it came back the following day, 12:40 something a.m. or so. Oh, aye. So we are praying. Today that is 8 something. I pray that it comes back. Anyway, so thank you for joining tonight's session. It's been great having all of you. Try and join very early so that you can learn a lot. How many of you would testify that you've learned a lot in this fast-paced session that we are doing? These ones are properly organized, as you can see on your screen, and so it will help me to be guided in the movement, as you can see. So I've also, these are not arranged according to how she has arranged hers. You get me? These ones are arranged logically for every step to make sense. Do you get me? And I'm strictly using our syllabus from our department where the questions will be set. So don't take these classes lightly. Okay. So those who have the opportunity to be here and they are not here, I pity them because a lot of things will be dropped lightly. All right. So thank you very much. I will meet Mr. Kote. Can we make something happen for me to take tomorrow's session? If it won't, if it's not possible, that's fine. That's fine. We would, it's possible, so that we continue tomorrow on the topic. So God willing, tomorrow we will do the where is it? Oh, why? Show your head. I think it's number 4, right? ER modeling. Then we'll quickly jump. I am trusting God for us to enter into the next 2 topics and then we kill it from there, right? Because we will just finish right on time. It's plenty, but we are doing it so that you understand it. Then now anywhere they pass it, you will get it. You see, just like So some of you can even do programming after here, database management after here. All right, thank you. Have a good night. Until then, it's bye-bye.